So here's a question. What are the maximum and minimum, the maximum and minimum, of y equals x squared, but this time on a closed interval. So this is extreme values on an interval. All right, so what that means is like, you know, I have, I'm monitoring, let's say, customers who come to a store, and I want to know the highest number of customers that were in the store between 2 and 3 p.m. Okay, so if there were more people after 3 p.m., I don't care. If there were fewer people before 2 p.m., I don't care. I only care about that window from 2 to 3 for whatever reason, okay? So that's the kind of problem that we're looking at. So, you know, this you can solve actually without any calculus at all if you think about it, because you know what the graph of y equals x squared looks like. It looks like this. There's y equals x squared. All right, so I know where y equals x squared has a min. It has an absolute min right there at x equals 0. All right, but I don't care about that min. I only care about the interval from 2 to 3. All right, from 2 to 3. So I only care about this interval in here. All right, so what is the minimum value that the function attains? Whatever this value is, which happens to be 4. What is the maximum value? Whatever this value is, which happens to be 9. So we have a min at 2, 4 and a max at 2, 9 on the interval 2 to 3, and that's a closed interval, okay? By the way, what if it was an open interval? So what if I had this? What if I had, here's, what is that, 1 minus x squared, all right? There's 1 right there. So here's 1 minus x squared, all right? Let's say I want to know the max and min on the open interval -1 to 1, okay? So this time I have the open interval from -1 to 1, and I want to know what the maximum and minimum value of the function are on that open interval. So first of all, I can clearly see what the max is. You know, I could do y equals x squared, dy dx equals 2x, 2x equals 0, and solve for that critical point. And then I could do first derivative test, where's f prime. All right, you could do all that, but look, the maximum is right there. We know what the graph looks like. All right, so we know that the max is 0, 1. All right, but what about the minimum? What do you think the minimum value we achieve on this interval is? Oh, yeah. So because it's an open interval, we never include whatever the lowest value is here. All right, the lowest value here is 1, 0, right? But we never include 1, 0. 1, 0 is not in the interval. All right? So what should be the minimum is excluded. So you can get numbers, no matter what number, this is like that, what is the smallest positive real number question. I can get as close as I want to this point, 1, 0, but I can't touch it. Any closeness that I want to get, anything that I want to say is the min, I could go closer, and then that's the min. All right, but that's not the min because I can go closer. So basically nothing is the min. There is no min on either side. There is no minimum. And these statements both apply only on the interval -1 to 1. So you have to watch the context too, because like this is a point, x equals 0, y equals 1. This is an interval. -1 is less than x is less than 1. The only way you know the difference between those two is by context, okay? So that's what happens when we look at max and min on an interval. So now we're going to look at a specific example of one of those problems next.